Hello guys, today we will be learning about applications of galvanized cell, applications of electroplating, applications of electrolysis, and each of those respective labs. Now, without further ado, let's dive straight into the video. Isn't it interesting how galvanic facial therapy uses the currents generated from zinc and copper, the difference between them, to have benefits such as hydration for the skin, anti-inflammatory effects, and collagen production, which copper is known for. The pros should be that this zinc and copper complex can be bought like online. You can buy it online to use it for your own self. You can use galvanic facial therapy on yourself on by buying it online. The cons is that you're not a professional, so if you do it wrong, your skin is gonna get damaged, you're gonna get dry, and you're gonna have to pay to meet a dermatologist. And usually dermatologists are very expensive just because they're specialized doctors.
So for this experiment, it was about galvanic cells. The lab apparatus used were your typical beakers, voltmeter, alligator clips, and the provided substances by our teacher. These substances include copper, zinc, and aluminum, and magnesium. For the experiment we chose, we decided to mix copper with a graphite rod to check its voltage. So firstly, we dipped the salt bridge into the measuring cylinder to attain our salt bridge. Keep in mind that it should not dip into the solution entirely, as it will as you should be holding it with either forceps. Just make sure it doesn't fall into the measuring cylinder. After that, we place the beakers into position and place the salt bridge to connect the two. Second, after that, we decided to connect the graphite rod first, but to the alligator clip that is connected to the anode. Keep in mind
We'll put
that
it dipping it
the
in.
Yeah, graphite rod
I mean, like we could just reuse
should be in the
dipping
solution,
it.
but it should not fall
It's the same thing,
into the
so
solution with the alligator clip.
soak
As you can see in our footage, we made a slight blunder, as we had not expected the graphite rod to just fall in,
graphite,
and this
which is not reactive.
affected our results,
I'm a bit
which made
worried.
it
Let me
anomalous.
just
So either hold it or position it correctly so it doesn't fall in.
bro, how am I supposed to attach it?
After that blunder,
Squeeze it
we
harder.
connected
Yeah.
the cathode to the copper to the copper wire. After that, we put both in the beakers and checked for reading. And sure enough, despite our previous blunder, we had a reading, although this reading is most likely anomalous at 0.1 volts.
Is it rice? Yeah, it is.
Electricity doesn't just power our homes and phones, it also powers chemical changes that shape our modern world. Two such processes are electroplating and electrolysis, essential techniques used in science, industry, and even art. Let's begin with electroplating. What's electroplating, you might ask? Electroplating is a process where we use electricity to deposit a thin layer of one metal onto another. This is done in a solution called containing metal ions. The object to be plated acts as the cathode, the negative electrode, while the metal to be deposited acts as the anode, which is the positive electrode. When electricity flows through the solution, metal ions move and coat the object with a smooth, shiny layer. Electroplating has a wide variety of uses. Let's look at some of the more common examples. Jewelry. Gold plated jewelry is everywhere. Instead of using solid gold, manufacturers plate cheaper metals like copper or brass with a thin layer of gold to give them the same look for a much lower cost than using solid gold. Electronics. It's no surprise that electroplating is also used for electronics. With metals like gold or silver, it improves their conductivity. That's why the connectors in your USB cables, circuit boards, and even SIM cards often have thin layers of these precious metals. Automotive industry. Vehicles are no exception. Car bumpers, bike parts, and wheel rims are often plated with chromium for a shiny finish and, of course, more importantly, resistance to corrosion, cutlery, and cookware. Many kitchen items are electroplated with nickel or silver to prevent rust and give them a more polished look. And even the medical industry is included. Instruments like surgical scissors and forceps are often electroplated with chrome to make them sterile, durable, and rust resistant so they can, do their jobs properly. Now, let's explore the concept of electrolysis. Electrolysis is the process of using electricity to break down the compounds into their basic elements. This involves passing a direct current through an electrolyte, typically from another power cell, such as a DC power supply, for example, a liquid that contains free moving ions. Electrolysis requires two electrodes, the anode and the cathode, much like electroplating. When the current passes through, chemical reaction happens at both electrodes, causing decomposition. Now, much like electroplating, electrolysis is also used in a lot of places in the modern world. For example, in the extraction of metals. Electrolysis is used to extract reactive metals like aluminum, sodium, and magnesium from their ores. For example, aluminum is extracted from bauxite ore using molten cryolite in the Hall-Héroult process. Without electrolysis, we wouldn't be able to isolate and extract these metals efficiently. Purification of metals. Even after extraction, metals often need to be purified. In copper refineries, for example, impure copper from smelting is refined using electrolysis. Pure copper gets deposited on the cathode, while impurities fall off or form sludge. Water can also be split apart, as in it can be split into hydrogen and oxygen gases using electrolysis. This reaction is important for producing green hydrogen, a potential clean fuel for the future that is currently still being explored. Electroplating and electrorefining. As we've already seen, electrolysis is also the underlying process using electroplating and metal purification. In this, and we also have the chlor-alkali industry. In this process, saltwater brine is electrolyzed to produce chlorine gas, hydrogen gas, and sodium hydroxide, essential chemicals used in making PVC, bleach, and soaps. Removal and restoration. Electrolysis can also be used to reverse rusting. Old tools and antiques are cleaned using electrolysis by turning the rust or iron oxide back into iron. Electroplating and electrolysis are not just lab techniques. They have massive industrial importance in our world today. They can help reduce waste by reducing valuable metals from scrap, and they support the green energy transition by producing clean hydrogen. They play a key role in manufacturing, electronics, aerospace, construction, and even healthcare. So let's just recap real quick. Electroplating adds protective or decorative metal coatings to everyday items like jewelry, cutlery, and car parts. Electrolysis breaks down substances to extract or purify elements, split water into fuel, and clean old objects. Together, these processes demonstrate how we can use electricity to control chemistry, shaping the materials, machines, and tools we rely on every day.
During our first trial of electroplating lab, I thought we messed up because the values of the amps was decreasing rapidly, and I heard a sparking sound, so I thought it was ours that sparked. So I thought the reduction in amps had to do with something we messed up in the lab. During trial 2, I quickly realized that we did not make a mistake as we didn't drop the alligator clips like last time, and instead it was just the copper that decomposed, and I thought that if it didn't decompose, so the amps shouldn't be dropping in the first experiment. In this lab, the anode was the copper and the electrolyte was copper sulfate, so copper could be oxidized into the solution so that the cathode could get coated, and the cathode here was graphite. In the lab, you can observe that the graphite got coated and it looks like slightly copperish in color. During our first trial, the amps was kind of weird, so the Faraday's number we got was still fine, but our theoretical value we got for the electroplating was kind of wrong because it's the current amps that we have to use, but the amps that it was most at was like 0.01, so the theoretical value we got was different from the actual value we got, far different, so the value we got for the percentage yield was 7%. After doing a trial 2, we fixed the errors we made, and the percentage yield we got during the second trial is probably more accurate and is 77% percentage yield. So for the electrolysis lab, it was actually the first lab in which our trial 1 we didn't mess up anything and did everything correctly. Okay, as you can see, in the anode oxidation occurs, as you can see from the brownish gaseous kind of thing forming and going into the circuit, like it's going to the other direction, going to the cathode and trying to reduce it. So when it eventually gets reduced, you can see in the cathode that like bubbles form, and those bubbles are hydrogen gas and hydroxide ions left in the solution. So you can clearly see the bubbles forming, so those are the hydrogen gas, and the brown gas that you see forming in the anode side is the iodide ions that lost electrons. Okay, so we added a starch solution at the anode side of the U-tube. As you can see, it turned blue-black. This is a confirmation of the presence of that iodide was oxidized and it formed iodide ions, as the iodide will react with starch. The result should be a blue-black color that forms. The role of phenolphthalein in this experiment was to check the alkalinity of the solution. If it is alkaline in the cathode side, it should be turning pink, which it did. It tests the presence of OH-, which if everything went correctly, H2 gas should be released, which leaves OH- in the aqueous solution, which makes the solution alkaline, as OH- is the main factor that makes a solution alkaline. So the second trial we kinda messed up. The graphite fell into the solution, so we couldn't really test for the using the universal indicator and test the pH levels of each solution. The cathode side and the anode side solution, we couldn't test the pH level, so we had to like be a bit. For some of the results in the lab, we had to roam around the lab, socialize with our lab workers, and check the results, compare with our results, and just take the results and get our results. YouTube, 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 YouTube. I don't get what's the hype behind YouTube. Oh, sorry, wrong YouTube. Is this YouTube? It is called U-tube. Get it? It's just a U-shaped tube. Now this is what we used for our lab. So I couldn't find this because I was thinking it was this YouTube. So I was struggling finding the YouTube play button during the chem lab. Although it might sound kind of dumb, that was literally what I was struggling with. So now that we know this is YouTube, let's move into what we got wrong during the lab. So this is our first lab, and we did everything correctly during the first few labs, but then all of a sudden our alligator clip, which looks something weirdly like this, my drawing is kind of terrible, but bear with me. So this clip thing, it dropped into the water. So then it probably got rusted because of us, but that one clip did not work. So then no electricity got produced. That sucks. So that one experiment where it was graphite here, if I remember correctly, it was graphite here. Graphite. And that was copper, if I remember correctly. That's Sch4u. Okay, that's copper. So this was fine, but the alligator clip for graphite, I don't know why, suddenly just dropped in. So then, learning from that, in our second experiment, in the second lab, we learned that we had to be safe with the graphite, the rod with the graphite, the alligator clip with graphite. So what we did was simple. We clipped it. We put the clip like above the graphite and bit it like the alligator bit it. Sorry, my drawing sucks, but never mind that. I think this looks more like a house than a alligator, but you know, I'll move on. So we did this so that it doesn't drop into the water, because the water has like a lot of scary stuff which could cause rust to the metal alligator clip. So then we put the copper in. Okay, so here's the mistake we made. During this experiment, we put it in for too long. Although it already corroded, we were like, hey, what's up? Why is it decreasing? Why is the voltage, why is the amps decreasing? It shouldn't be done, right? Because from our perspective, we saw this part was still visible to us. So I thought the amps is decreasing, and I heard like a voltage sound. It was probably not from our beaker, but I still heard the voltage sound. So I was like, I heard the voltage sound though. I heard it. Our percentage yield was kind of messed up the first time we did it. So this is the first trial. 77.8 is the second trial. So what we learned from this, we used in our third lab, which the alligator clips did not drop this time, thankfully. It did not drop to the solution. So we did this, everything correctly the first time around. But then I got too complacent. So the second time around, I was doing it to check for the universal indicator, and then the alligator clip did not drop, but the graphite rod dropped into there. So the solution was there. I couldn't pick it up because I didn't know if the solution was toxic in general, but in a lab it's best not to risk it. So I just washed it down the drain, but it was already 8:50, so I did not want to risk it and do another lab experiment. So I just went off to my next class. Moving on to applications. The summary of applications is basically, if you are doing electroplating, be careful of scams, man. They tend to scam you with spoon. Let's say you coated a spoon with gold, outer layer is gold, AU, gold, but then the inside is just plain old steel, man. Plain old stainless steel. Now, I'm not saying that stainless steel is bad. It is good because it doesn't get rusted, unlike iron. But you're not paying for gold, you're paying for stainless steel, which is much, much cheaper. The only gold you get is on the outside. Just like how food places, like let's say you have a Wagyu piece here. You have a Wagyu, let's say that's a Wagyu piece. Okay, they coat this part with gold, they put gold flakes, and they justify their 10,000 USD as a gold plated Wagyu. But that's not the case. The actual meat is just 1,000, and the gold plating that they use is like $5, man. $5. Although I haven't researched too much about it, galvanizing facial therapy is also kind of a scam. Because watch, let's say you buy it from Temu, the number one not trustable app for like facial therapy. But never mind, let's say you buy it from Temu, it's like 30 ringgit. It's probably not working and fake, but you know what, it's 30 ringgit. And now let's say you buy from a hospital, it's gonna cost like 300 ringgit. What the hell? 10 times the price? How is this fair? Okay, so now let's say you're a person. You do like, you put cucumbers in someone's face for the benefits. Okay, how much does the cucumber cost? Maybe like around $2 at most, maybe even $3. Okay, now you do the same exact thing with a dermatologist. How much does it cost? $300. Why? It's the same thing, but this guy is a professional. A professional scammer? I'm not sure. But he's a professional at stealing your money? Yeah, true. To summarize, do not get scammed by electroplated materials, and don't make the mistakes we did in our lab, and don't go to the dermatologist unless you really need it. That was just a brief summary of what we learned today. Brief summary. Now, thank you. And for more, subscribe.